Distinguished participants, we would like to begin session 1. Please be seated. The topic of session 1 is the prediction and warning service of space weather, and Mr. Koo Jong-mo from Korea Space Weather Center will serve as a moderator. Good afternoon. I will serve as a moderator for session 1. My name is Koo Jong-mo. I will moderate being seated. And thank you very much for your participation despite your busy schedules. Session 1 will talk about the 24/7 prediction and warning service of the space weather. Every 12 years, there is the solar maximum, and there are increasing risks of the space weather disaster. In this case, we need to carry on the R&D projects, and we also need to have the prediction warning service for the ionospheric disturbance and geomagnetic disturbance as well. So we will learn about this. In session 1, we would like to invite 4 speakers to the stage, and each speaker has a different time allocated. So I would like to ask speakers to check on your time, and please spare some time for Q&A. And as for the Q&A session, we would like to select some questions and give the answer for the selected questions. The first speaker is Mr. Yoo Jae-hyuk from Korea Space Weather Center, and he will talk about the R&D projects in the Korea Space Weather Center.
안녕하십니까.
Hello everyone.
국립전파연구원 우주전파센터 기획협력팀 유재혁 중원입니다.
My name is Yoo Jae-hyuk from Korea Space Weather
23년부터
Center.
27년까지
And
저희
from
센터에서 추진하고자 하는
2023
R&D
to
사업
2027,
사업명
the
우주전파
Korea
재난
Space
예측
Weather
및 대응 기술
Center
개발 사업에
will
대해서
run
간단히
R&D
설명을
projects.
드리겠습니다.
So I would like to give you the overview about this project. So let me first introduce the background overview of the program, the investment plan for each year, and goals for the different projects and expected benefits. This is the background of the program. As of now, in 2022, we are in cycle 25, and the solar maximum will begin from 2024. From 2008 to 2019, there was a high activity of the sun. And there are more than 200 warnings in RSG level. So when there is a solar maximum, there will be more space weather disasters. In the meantime, in Korea, we are faced with the fourth industrial revolution and development of future mobility technologies. And at the national level and the local government level, UAM, satellite, and autonomous driving cars are introduced. In this sense, when there is a space weather disaster, there will be lots of disasters expected. And in this sense, the Korea Space Weather Center to prepare for the solar maximum, and in order to protect the infrastructure for the fourth industrial revolution from the space weather disaster, we think we need to carry on the R&D projects. So the vision is a safe environment for the radio wave resources, which serves as a basis for the fourth industrial revolution. And we would like to enhance our capability for the observation and prediction in the space weather disaster, and we will provide stable support for the fourth industrial revolution. And we would like to develop the prediction system for the space weather disaster based on AI. And in the near Earth environment, we also would like to develop the prediction and warning system. So in total, we have 6 projects. So under these two strategies, we would like to develop the solar surface magnetic field map based on AI, and we would like to have a prediction model for the occurrence of the sporadic E and improve algorithm for observing space weather disaster. And as for the near Earth environment, we'd like to develop the forecast model for low Earth orbit space weather environment, develop prediction model for the arrival of the solar wind and solar particles, and study advanced system and technology for responding to space weather disaster. So these are the investment plan. And in total, for the next 5 years, we will invest 950 million Korean won. And as for the AI-based prediction system, will invest 505 million Korean won, and for the prediction system for the near-Earth environment, will invest 450 million Korean won. So this is the AI-based solar surface magnetic map development. In particular, we'd like to focus on the backside of this sun and the edge of the sun and high altitude. And we would like to develop the map that can be applied directly to our research. And this is the second one. We would like to develop the prediction model for sporadic E. In Korea and in East Asian region, we can see frequent appearance of the sporadic E. So we would like to make a prediction, and by studying about this and predicting about it, we can supply this stable, high frequency usage environment. There are various geomagnetic activities and solar activities. So sporadic E statistics will be analyzed, and we will do the characterization and come up with the environment where sporadic E appears. And through machine learning, we would like to develop the model. And for the prediction and warning, we would like to establish the system so that we can utilize the data. Third, we will develop the algorithm that can be used for the observation of the space weather disaster. We have the solar activity observatories and geomagnetic induced current observatory as well. So algorithm will be enhanced, and in our center we are using the device for observing the solar activity, and we also have the 2.8 gigahertz observation device, and we also have the observation device for the geomagnetic induced current. So these devices will be enhanced. Fourth, we would like to develop the prediction model for the low orbit space weather environment. At the surface of the sun, we would like to observe the radiation and the radiation belt and experiential statistics model, and depending on the time and area, we would like to have a surveillance model. Fifth, this is the fifth research project, developing the prediction model for the solar wind and solar particles. When there is a solar storm, we would like to respond rapidly. So CME will be automatically detected, and we will predict the high energy particles arrival to the Earth. In the past, we developed the model already. So at our center, we are using the model, so that will this anneal will be connected to this new project, so that we can predict the CME. And by using the characteristics of the flare and solar wind, we would like to predict the intensity profile of high energy particles depending on the location. And this is the sixth project. And this is the internal project in our center. We would like to advance the system and technology for the responding to the space weather disaster. So domestically and internationally, we would like to learn the trend for the space disaster, and with the change of the industrial structure, we would like to do the investigation and study about the space weather disaster and enhance our capability to respond to the space weather disaster. And through these six projects, we expect that we can minimize the discomfort to the surface to the service in the fourth industrial revolution using the radio wave, and we can establish the prediction and analysis system customized to the Korean Peninsula, so that we can stably support the national space development programs. And last but not least, we believe that we can ensure we have the source technology for the AI, big data, and space, as well as IT, and have the future growth engine in the industry. With this, I would like to conclude my presentation. Thank you very much. Thank you very much for the presentation. If there is any question, please raise your hand. If not, I would like to ask a question. Along with your presentation, do you have any other R&D project? We have the framework plan for the space weather disaster, and a low orbit satellite and satellite constellation will be developed. That was the previous R&D project, so that was included in the previous project, and we also have it in the framework plan. So for the launch of the satellites, we need to do the research and development, and that will be carried out after 2023. So we'll make efforts so that we can make it as a program. If there is no other question, please give a big round of applause to Mr. Yu Jae-hyuk.
Next, I would like to invite Mr. Yoon Jong-yeon, researcher from the Korean Space Weather Center. He is going to talk about the forecast and warning service of the ionospheric disturbance. So, Mr. Yoon. Good afternoon. I'm Yoon Jong-yeon from Korean Space Weather Center. Currently, I'm working on the studies of the ionosphere at KSWC, and I'll talk about the forecast and warning service provided by the KSWC. I would like to briefly talk about the ionosphere and the monitors that we operate. Before I talk about the ionosphere, I'd like to explain some terms. There are many people who use different words to talk about ionosphere, and there are some people who argue that we have to unify and harmonize the terms that we use. And in Korean, it is recommended that 전리권, the ionosphere, is used. According to the Radio Wave Act, the word ionospheric layer is used, but it should be changed into ionosphere. So the ionosphere has a number of layers, so we have to change the Korean term. And to match the English term as well. And so instead of using the ionospheric layer in Korean, we'll have to understand that there are layers in ionosphere, so we'll have to change the Korean term to 전리권 to really represent the English term ionosphere. So I'll use the term 전리권 in my presentation. Ionization occurs in ionosphere, and the solar energy is absorbed and the number of electrons increase, and during the nighttime and the thickness of ionosphere is reduced. So that's the characteristic of the ionosphere. As you can see from ionosphere, it's a combination of ion and sphere. So it has ions. There are ions in ionosphere, and we provide forecast and warning because the ionosphere is closely related to satellite communications, our cell phones and navigations, and other GPS positioning and shortwave radio communication. So we understand the ionization process in the ionosphere. And there is D layer, E layer, and F layer in ionosphere, and different layers have different wave bands. X-ray is absorbed in layer D, and there are also EUVs. Up until D layers, X-rays are really important. And X-ray is closely related to solar flare. And in the event of solar flare, X-rays enters the ionosphere and it impacts the D layer and it increases the electron density. So that's the basic that you will have to understand. To give you more details, F has the biggest electron density, and at E layer and D layer, the electron density is lower. And the D layer is the innermost layer, and it is 48 kilometers to 90 kilometers above the surface of the Earth. And for HF frequency communication, the waves goes to the F layer and it's reflected to the lower area. And if there is any disturbance in E layer, and the signal will be impacted and it does not reach the F layer, and that causes the blackout. And if there is a sporadic E layer, then it can disturb the signals, and if X-rays can cause the Dellinger phenomenon, then the signal that are supposed to reach the F layer will be absorbed in layer D, and that can cause telecommunication a blackout, and that is referred to as the Dellinger phenomenon. And we should be able to provide forecasting and warning services on such events. We have 이천 and 제주 monitors, and Korean Space Center is the only organization that operates such ionosphere monitors. But the monitor radius is about 200 kilometers, so Icheon and Jeju facilities are sufficient. But in Ulsan and Busan region, in Gyeongsang province, we don't have any coverage. And if we have to install another monitor, that should be located near Busan so that we can cover the entire Korean peninsula. So we are considering the feasibility of installing another monitor so that we can monitor the entire ionosphere over the Korean peninsula. So we have the transmitter and the receiver antenna. And the frequency between 1 to 30 megahertz is transmitted, and then its reflected frequency is used to analyze the ionosphere. And we look at the changes of the, for example, electron density of the ionosphere over the Korean peninsula. And the observed values, As you see, there are color-coded graphs, and FOF2, the critical frequency of the F layer, and there's also FXF2, which is the. So we have to extrapolate the FOF2 and HF2, and based on such values, we run the models, and we can also calculate the frequency availability. Of course, we have the existing monitors that run 24/7, and those have been in operation in a stable manner. But since 2018, because of the aging of the monitors, we experienced the underperformance of the transmitting and receiving antennas. So we have secured some budget, and in 2023, we're going to replace the existing facilities with new ones so that we can maintain the continuation of our data collection. And so we are now considering installation of new monitors. As you see in these diagrams, there are some major changes between the normal data and abnormal data. So if you look at the F2 layer and the HF2 layer, there is a significant difference. So for us, it is critical to provide normal data. So next year, we'll make sure that we install the new monitors so that we can obtain quality data. So we have the new antennas that we are planning to purchase, and we should be able to operate those monitors in a more stable manner. Now, I will talk about the forecast and warning service on the ionospheric disturbance. I'd like to talk about the characteristics of the ionosphere over the Korean Peninsula. And I'd like to first say that it never follows our expectation. The solar energy is received in the ionosphere, and because of that, the thickness is increased during the daytime. But there are a lot of different atmospheric activities, and there are also a lot of energy that comes from the Earth, and there's a lot of dynamics. It's like the air and weather conditions. The dynamics are quite complicated. So it does not really follow our insight. So if you look at this diagram, the ionosphere changes depending on the solar activity cycle or the solar cycle. As you know, the solar cycle is 11 years, and the maximum and the minimum period changes every 11 years. And the ionosphere, the F2, the critical frequency increases and the electron density increases. But if at the solar minimum, the electron density goes down. So this is what we have as understanding. But there are also seasonal changes, and it does not follow our insight or our common sense. We assume that when there is the bigger solar energy during summertime, we anticipate higher electron density, and we anticipate lower electron density during the winter time, but that is not the case. During the summertime and along the equator, we assume higher electron density, but actually higher electron density is observed at 20 degrees longitude. And if we consider the seasonal anomaly, for Korea, we will have the bigger changes or a higher electron density during fall and springtime. We also analyzed some relevant data, and we were able to identify two peaks during fall and springtime and the lower values during summertime. For HF communication and for military operations, this characteristic should be understood. And based on our understanding, we can also improve our forecast and warning service. And there are also daily changes. And during daytime, at noon, we see the peak. And of course, the value is the lowest during the nighttime. Now I'd like to talk about the ionospheric disturbance and the type of damages that it can cause. Because of solar flare and because of such solar activities, there are some changes in the ionosphere, and that can have significant implications in various industries. There could be blackouts, and there could be scintillation, and HF and GSS signals can be impacted. For example, we can experience communication blackouts, and with the X-rays in the ionosphere, the electron density increases in layer D, and that can reduce the available frequencies, and it can also disrupt the shortwave radio communication. On the left, 5 megahertz can be communicated with Daejeon, and typically the signals reach the F layer, but with the Dellinger phenomenon, because of the X-rays, the electron density increased significantly at D layer. So when 5 megahertz of communication occurs, the communication signals are absorbed in D layer, and it is reflected at layer D. And these blackouts can occur, and right after R3, we obtain data from our monitors, and you see a complete blackout occurred because of the solar flare. And after 50 minutes and 60 minutes, you start to see the recovery of the situation. So the solar flares can cause a complete blackout or disturbance, a great disturbance in communication. So we really need a warning service. And in sporadic E layer, there are a lot of ground influences. Sporadic E layer is really important because in Northeast Asian region, we tend to see more sporadic E layers appearing, and it can impact HF and VHF communications. And it is really difficult to forecast sporadic E layer appearance, but maybe it is still meaningful to provide some relevant data. That's why we are conducting a R&D project on this. So this is a diagram of sporadic E layer. If there's a sporadic E layer created, a thin E layer can interfere with the telecommunication frequency. Geometric disturbances can be also caused by ionosphere, and this is FF2 serial graph. And there is a pattern of the previous 5 days, and on November 4th, you see that there is a big difference between the peak and the trough. So G3 event occurred, and because of the geomagnetic disturbance, we were able to see this huge peak and trough. And geomagnetic storms can also cause ionospheric disturbance. And this is also an important ionospheric disturbance that we can also include in our forecast and warning. There's also spread F layer, and also I talked about the sporadic E layer, and L band signals can be impacted, and because of the pager change, the quality signal can be undermined, and this is what we are also working on as our forecast and warning service. And now talking about the actual service that we are planning to provide. This is how I can summarize the ionospheric disturbances. There are some elements that are related solar activities, and there are also geographical characteristics of the mid-longitude regions. But when it comes to real-time warning, if there is a solar flare, we have to identify whether there is a Dallinger phenomenon or not. And also, if the sporadic E layer is created, then we will have to warn the public about it. And if there is a geomagnetic storm or disturbance, if there is any significant changes in the electron density, we can provide also a real-time warning. And also there could be geomagnetic disturbance that is related to the higher level of energy coming to Earth. And unfortunately, we don't have a plan to include that in our warning service. So this is an example of the 3-day forecast, which is based on RSG class. We analyze the previous 24 years ionosphere, and we provide a 3-day forecast on the ionospheric disturbance. And there are some probabilistic figures, and the likelihood of the communication disturbance is also provided, and the MUF change of the next 3 days is being provided as well. The MUF 500 is now being provided, and because we developed, it was possible because we developed the ionosphere prediction model some years ago, and based on this model, we provide predictions for the 3-day MUF 500 changes. And it would be really ideal if we could provide forecasts on sporadic E layer, but as you all know, this is quite challenging. And in 2023, we will launch a related R&D project, but we all understand that this is quite challenging. Maybe we could utilize deep learning technologies so that at least we can provide some information that the users can refer to. It could be every month or it could be every hour. So we'd like to provide at least some level of information. And talking about the warning service, we don't provide the warning service yet. We only have a plan. But communication blackout can be notified. And our target is to notify the Dallinger phenomenon happening in Korea, and we can also warn the general public of the time and size of the telecommunication blackout. And we can also warn about the sporadic E layer, and we can also have scintillation warning, which can have some impacts on satellite signals. So we are planning to include these warning services step by step. Talking about the communication blackout, I already presented these ideas in other occasions, and I understand that it's likely, or this could be possible, and later we'll be able to launch a warning service on the Dallinger phenomenon with D layer and D-rep model. Depending on the solar genetic angle, we can understand the D layer changes, and there are also benefits, and it can also realize a real-time warning. And concerning the sporadic E layer warning, so we can use our observation data, and currently we are looking at the 7 megahertz and 10 megahertz as the criteria for our sporadic E layer warnings, and we are thinking about issuing level 1 and level 2 warnings based on the FOES. And we can use the S4 index observation data. There are some previous researches conducted, and utilizing the outcomes of the previous statistics, we can use the criteria of S4 0.3 to 0.8 to issue warnings on scintillation. So when there is a solar spot maximum for the Korean users, we are planning to provide swift and accurate information. So that's the end of my presentation. I'd like to thank you for your attention. Thank you very much for your presentation. Is there any question from the floor?
질문은 아니고 그냥
It's not a question, but I have an ask or a comment.
일단 발표 예전에도 이제 우주전파환경 컨퍼런스나 참석해봤을 때
When I attended other similar events or conferences,
전문성을 가지고 이렇게 발표를 해주시는 걸 보니까 너무
it was really good to hear presentations like this in those events.
모델에 대해서 얘기를 많이 해주셨는데
A lot of talks were related to the prediction models, but as you all know,
차세대 2명 이상의 전리권 관측을 위한 인스트 메저먼트 이런 터치체를 개발을 하고 있고
we are now developing the payload, which is the instrumentation device that will be mounted to the next generation satellite to observe the ionosphere. But my request here is that,
아까 서성일 원장님께서도 말씀을
as was mentioned by the
하셨습니다마는
administrator 서성일,
산하견 군반 이렇게 되는데
there are academia, research institutes, and the Korean Space Weather Center is part research institute and part government agency.
그동안에 우주 환경, 그다음에 우주 과학 이런 타이틀을 가지고
There are
어떻게 보면은
space environment and space science related institutions.
서바이벌 하는데 급급하게 흘러갔다.
But a lot of activities of those organizations were not really geared toward researching or technology development, but a lot of activities were really to ensure the survival of those organizations. But now that Korea is one of the space superpowers in Korea, and also the Korea Space Weather Center may have future plans to own and operate its own satellites. But now that whenever we attend this type of conferences, I do not see a lot of students in the audience because we've been focusing on the survival of the organizations. And we are not really working on the projects that we are supposed to pursue. I understand that your monitors are located in Jeju Island. I do understand you're really working hard on Jeju Island, but I hope to see more collaboration among related organizations, and maybe we should help each other and work on the same longer term goals. I hope that the investment will also follow in that regard. And I hope that there will be a lot more opportunities for different organizations to work together. I totally agree with you, and I myself also want to be part of such a larger collaboration. But it's really difficult to, or rather, it is really important to nurture our future talents. So I hope to be engaged in such endeavor, and I also want to be involved in related activities. Thank you very much for your presentation. It was really useful. So X-ray data is now being distributed on a real-time basis, and my question is,
엑스레이가 전리청에 상당히 영향을 주고
So the
있는데
X-rays can have a lot of impact
엑스레이 데이터를
in the
활용해서
ionosphere. Maybe we can use the X-ray data,
외경보에 활용하고
and you're
있는지
using,
여쭙고
or I'd like to
싶고요.
understand whether you use the
그다음에
X-ray
만약에
data
그렇게
to
한다면
warn the ionospheric disturbance. If
데이터 활용에
in that
혹시
case,
애로사항은
I'd like
없는지
to know whether you
하고요.
encountered
그다음에
any errors in your
엑스레이
prediction.
EUV가 전리청에 상당히 영향을 많이 준다고
And
말씀하셨고
X-rays and EUVs
이런 간첩을
can cause a lot of
국내 독자
disturbances in
간첩의
ionosphere,
필요성에 대해서
and
혹시 생각한 게
I'd like
있으시면
to
좀 듣고
understand your
싶습니다.
thoughts on our independent monitoring.
저희가 알정보라고 하는 전파 조절 정보는
So we have the R warning, which is radio blackout warnings, and we use X-ray data.
고지 위성에서의 X선 유입량을 가지고 판단하기 때문에
And we use the GOES satellite data.
알정보는 발생을 하거든요.
So our warning can be issued when the time is the night in Korea.
알정보는 그렇게 활용이 되고
So we do have our warnings, and because of such the merits, as was shown in my slides,
고지 X레이에 기반한 정보보다도
instead of GOES X-ray based warning,
전파 조절을 발생할 수 있는지
we're going to utilize our proprietary model to issue our warnings, and that's why we are conducting some related research. One difficulty is that during daytime, we don't have a lot of influence from the EUVs and X-rays. So we don't need to respond to these nighttime warnings. So we want to improve our warning system that is based on the X-ray of GOES or X-ray data that comes from GOES. Are there any other questions from the audience?
예, 제가 듣고 싶은 거는
What I wanted to understand was that
간첩의 그 국내 독자 간첩을
whether we want to have our own X-ray observation instead of relying on GOES, because we receive the services or receive the data from GOES.
국내에서
Maybe some will argue that
필요할까 하는
why we need to have an independent monitoring or observation, but still, maybe we don't have to rely on the overseas source, but can have our own system to observe the X-ray. As you all know,
위성에 우리나라가 개발한 위성에 우리나라 위성에 엑스레이 탑재체를 가지고 우리나라도 엑스레이 데이터 생산해내는 거
generating X-ray data from our own satellite will be an ideal situation.
GK5 차세대 전략도 지금
For GK5,
탑재체가 올라가는 게 지금 계획
we have a plan to have X-ray device. We haven't passed the feasibility study yet.
차세대 첨예한 위성이 운영될 수 있도록 지금 현재
So our plan is to have the X-ray device on GK5.
고지에만 좀 매달리는
So you don't want to be 100% reliant on GOES. So it will be really good if we can have our own satellite to provide X-ray related data. And if there is anything that we can do to support, we will do our best. Since the time is up, we will have to move on to the next presentation. Thank you very much. So once again, please give a big hand to Mr. Yoon Jong-hyun for the wonderful presentation.